This video is for section 6-4, Special Functions and Relations. A function or relation may be specified by different rules over different subsets of its domain. Take a look at this example. We have function s, and here's its rule. Sometimes function s is equal to 1, but only when the domain is x is greater than 0. Sometimes function s equals 0, but only if x equals 0. And sometimes the value of function s is -1, but only when the domain is x is less than 0. So function s takes on 3 different values depending what the value of x is. We can see the result in the graph. When x is any number greater than 0, meaning when you are to the right of the origin, the value of the function is 1, and you see the horizontal line for the constant function 1. When x equals 0, there's a dot right at the origin. And when x is any number less than 0, meaning when it's left of the origin, you'll notice the horizontal line at a height of -1 on the grid. Function s is an example of a step function. And no doubt you see why it's called a step function. It looks like it has steps, like stair steps. A step function is a type of piecewise defined function. That simply means the function is defined in pieces. Function s had 3 distinct pieces to it. Here's a function with 2 pieces. G of x equals x minus 1, but only when x is a number greater than or equal to 1. G of x is equal to 1 minus x when x is less than 1. Let's graph that so we see what the 2 pieces look like. First, let's graph the first piece of the function. X minus 1 is a linear function. Do you recognize the slope-intercept form? For example, the y equals 1x minus 1 form, where the slope is 1 and the y-intercept is -1. We can graph that. Here is where the y-intercept is -1. And a slope of 1 means up 1, right 1. Up 1, right 1. Up 1, right 1. It is a diagonal line running uphill. But the line does not cover the entire grid. Focus on the domain. Where is the beginning of that line? When x is equal to 1. Here is where x equals 1 on the x-axis. So this dot is where our line starts, and then as you travel to the right, we create this piece of our graph. Now let's focus on the second piece of the graph. This is equivalent to the slope-intercept form, y equals -x plus 1, where the slope is -1 and the y-intercept is +1. Let's graph that. Here is a dot at the y-intercept of +1. And if the slope is -1, you go down 1, over 1 to get another dot. Down 1, over 1. We could even continue to the left by going up 1, left 1, up 1, left 1. Notice the line going downhill on the coordinate grid. But we're not going to draw a line across the entire grid. Let's focus on the domain. We only have this downhill line when x is less than 1. Here is where x is equal to 1. X is less than 1 when you are to the left of that point. So we want this section of the diagonal line. Putting the 2 pieces together, it looks like a V shape. But this V shape has the 2 pieces, as defined in this piecewise function. Question B, what are the domain and range of the first piece? The domain is the x is greater than or equal to 1 statement. The range are the values of g that result when using numbers greater than or equal to 1. Looking at the graph is a great way to find the range. Look at this piece of the graph. You'll notice that the lowest value you ever have for function g is 0. And then it goes uphill from there. So the range is g of x is greater than or equal to 0. What's the domain and range of the second piece? The domain is the x is less than 1 statement. Now let's figure out what the range is. Again, using the graph is a great way to do that. Focus on this left piece. At first glance, it looks like the lowest spot on the left piece of the function is this dot here at a height of 0. But remember, that dot was actually on the rightmost piece of the function. The left piece of the function didn't actually ever use a value of 1 for x. So the range is g of x is greater than 0. Let's summarize the lesson. We discussed a kind of function called a piecewise defined function. It's built from pieces. These functions will have a name, such as f of x or g of x, and then rules will be given to indicate what the function is equal to. For example, sometimes it's x minus 1, and other times 1 minus x. For each rule, a domain statement will be given, so that you know for what values of x to use that rule.